enables us to explore trajectories of the Lorenz system, and the reason I'm making a screen recording is just that it can be hard to get Java to work. And so what we're looking at right now is the XZ plane, and R is set to 28, and we're about to see a time series plotted across the bottom. So I'm just going to click an initial condition, and we're watching X as a function of T. And then at some point, a second set of initial conditions were introduced, and so we can watch the two trajectories. This is their time series, and this is their position in the XZ phase space. Now, we can also start two time series quite close to each other. And so what we're seeing here is the distance between two initial conditions, and I'm going to do that again. So I'm going to clear right now and choose an initial spot. I'm going to pause. Right now, there's two trajectories in there, the orange and the pink, and they're so close together that they're basically on top of each other. E to the negative 8th distance is where they started, and right now they're at about e to the negative 4 apart. And I'm going to continue. And you can begin to see the dots are not perfectly on top of each other anymore. Soon they're going to be a distance order 1 apart. And then very rapidly they snapped to a distance of 2 to 4 apart, which is some portion of the length scale of this whole attractor. And from here on out, they're just going to stay at some substantial distance apart as they traverse the attractor quite separately. So I'm going to clear and show this once more. They start close together and very slowly they're growing apart, and then there's some distance apart that's on the order of the size of the attractor. So this is the XZ view of what the attractor looks like in the Lorenz system, and here's an XY view. And back to the XZ. And then finally, a YZ view. So there's what the attractor looks like from the YZ perspective. Of course, this is a pretty rough integration. You can see these long line segments. And then XZ. And then XY. In this applet, we're looking at the XZ plane, and we're just looking at 12 different values of R, and I can click on an initial condition, and we see approximately what trajectories sort of look like, starting from that initial condition for all these different values of R. So you can see that at some value of R, I might go to towards the far stable fixed point, while for a different value of R, I might land at the close stable fixed point from the same initial conditions. And then you can see that somewhere between 19.75 and 22, we begin to see this interesting attractor that's termed a strange attractor.